Hello guys, today I want to show a topic. My topic is vehicle trajectory estimation, and I use yellow based detection from drone data, and I compare this with extended Kalman filtering. So my work plan is over here. I use Links chain them intersection. Our intersection in Netherlands, the video quality was 4K 300 frame per second. And data cleaning method I used that I filtered those data and filtering for 1 second interval data because that data are very much fine. There are 30 frames per 1 second, so I filtered it to 1 second data, and some drone videos are not that much at good quality, some frames, so I distracted those. And visual trajectory, I use ground truth, that is yellow detected, and extraction using Python, and Kalman filtering base, extended Kalman filtering base to estimation, and comparison to validate my extended Kalman filtering model is vehicle trajectory, nominal root mean square error, and if you see here that average displacement average displacement error I used. And detail analysis, I divided detail analysis into 6 parts. Firstly, basic statistics. Secondly, car following parameters like headway distribution, speed distribution, lane changing behavior, like lane change duration distribution, shockwave analysis. For shockwave analysis, I use traffic density per over time, fundamental diagram, traffic flow over time. For safety analysis, time to collision distribution, I use also distribution of critical safety I consider. In vehicle dynamic criteria, I consider vehicle speed profile, vehicle acceleration profile, and acceleration distribution. And here is the flow chart of my roadmap. That is firstly drone data, video data are collected, then data are cleaned, and I clean and filter those data, which vehicle speed, vehicle displacement, especially the vehicle movement is less than 5 meter in entire video analysis. So those are actually immovable object. I want to discard those objects. And vehicle trajectory, I use ground truth and estimated trajectories using extended Kalman filtering and compare the validation, providing adequate plots and matrices. You will see it in the later phase, and detailed analysis is provided for traffic pattern analysis. And this is the drone video data and annotation. You can see the drone traffic footages of an intersection in Netherlands and corresponding annotated video. I use custom dataset and trained using YOLO 11 a model. So I can actually getting off from here want to show my the videos. This is the actually the original videos. I received it from YouTube. You can see this is the original video. And the annotated video that I use analysis using yellow, you can see the video over here. This is the yellow generated video. I use detection techniques using yellow. And let's moving again to the presentation slide. So left side, you can see that the drone traffic footage and corresponding annotated videos. And this is the extracted traffic vehicle trajectory data. The ground truth, firstly, we get frame. I just distracted the frame. We have time step, vehicle ID, position in X, position in Y, then ground truth. Ground truth is calculated using Euclidean distance. Then cumulative ground truth distance is measured. calculated actually. It's calculated. The first four column you can see is measured from the using the YOLO and Python code, and last two are calculated actually from the X and Y position. And this is the pseudocode for extended Kalman filtering based vehicle trajectory estimation. There are five steps. First one is initialize the EKF model, considering matrices and covariance and its initial state. Then predict each time step, considering the position, velocity, and acceleration. Then update the measurement, the position of X and Y, compute innovation and Kalman gain and correct the estimate, then iterate through trajectory, repeat, predict and update based on tiny steps. Then we consider position, velocities and acceleration. Lastly, post-processing, I estimated the position, compute trajectory distance, cumulative distance, and accuracy metrics that are calculated for the extended Kalman filtering based method. And we can see that there are two vehicle trajectory plot. One is obtained using uh, drone and YOLO custom dataset, and the right side is the extended Kalman filtering based prediction. We can see two vehicle trajectories side by side. And overall performance metrics, if we see that the normalized root mean square error is 0.013, which is very small, and average displacement error is only 0.626 meter. And if we see that from the basic analysis, we can see that the vehicle spacing comparison, the comparison with ground truth with EKF estimated spacing, and right side we can see that the vehicle spacing distribution histogram with mean errors, vehicle spacing errors distribution we can see in the right side. And here we have two graphs. First one is relative speed distribution and see the mean value, and next one is time headway distribution for ground truth and extended Kalman filtering. And in this slide, we can see that the distance over time for following and followed vehicle, leader and follower vehicle. Leader is 1 and follower is 3. For one sample pair of vehicle, we can see the following distance graph over time here. That both blue and red line are almost matched together. And next we have lane changing graph 1, and another graph is shock wave. For shock wave, that is traffic density over time. We can see that the lane changing duration distribution, the mean value is 5.65 and median value is 5 seconds for lane change duration histogram. And in the right side, we can see ground truth versus extended Kalman filtering based steps, that our density variation is over time, is fluctuating. And here we have two shockwave analysis. One is fundamental diagram, and another one is traffic flow over time. We can see the scatter plot and the line plot over here. Next, we have average speed over time. We can see that the variation, average speed over time here. And safety analysis, for safety analysis, I do time to collision distribution. Time to collision distribution formula is given here. That is in the numerator, we have x lead minus x follow divided by, in the denominator, we have velocity, that is speed of follow vehicle minus speed of lead vehicle. So calculating this, we can calculate the time to collision and calculate the time to collision distribution for all cases. And we can see that the median is 4.76, but the critical value is 2 seconds. And another safety analysis topic, that is distribution of critical safety events, are plotted over here. 5 second, less than 5 second considering the critical safety events, and less than 2 second considering critical threshold. We can see total 838 such events fall under this category. Since this is a signalized intersections, vehicles headway or time to collision gap is very low. So it's normal actually that there will be lot of such events, that almost 833 events are less than 5 seconds for TTC, considering TTC. And here we have two vehicle dynamics property. One is vehicle speed profile and vehicle acceleration profile. We know that the speed is the first derivative of distance over time, and acceleration is the second derivative. And for both ground truth and EKF estimate, we can see that the plots over here, scatter plots over here. And here we have acceleration distribution for both ground truth and EKF estimates. And we see that the is almost left skewed. And here are some literature, though I should give the literature in the first portion of my study, but there are actually five relevant paper. One paper discusses with tracking vehicles using Kalman filtering. They captured thermal video cameras, use YOLO V3, and this is actually journal paper in 2021, generates individual vehicle trajectories and cruise pattern. The paper two is use vehicle tracking and speed estimation using deep sort, and use surveillance video footage. And non-linear Kalman filtering are used for data association. They generate real-time vehicle classification and unique tracking ID. Paper 3 use same type of thing, aerial video-based vehicle trajectory generation, use high precision down to data with that for, and supporting navigation system and multi-vehicle trajectory dataset use. This paper is from maybe in 2026, use yellow V5, use Kalman filter to quantitatively evaluate vehicle box motion parameters, inter-vehicle parameters, and find some errors in bounding box near frame edge, and unrealistic velocity fluctuation at video stretching boundary, and distort, and this impacts distortion of downstream behavior analysis and safety risk assessment. They found it in the serial 3 paper. And in the fourth paper, drone video data analysis and occluded urban traffic monitoring are considering, and drone captured aerial footage are used, and they're targeting visual obstructed environment like tunnel and overpass. And for speed and trajectory observation, use quota algorithm. Yellow V8 is used. Bike track is used for tracking. Loftier is used for motion compensation, and map multi-directional flow through oculations. The system is robust for vehicle counts, speed estimation, and classification for both long and short vehicle. This is for reference 4. I have another literature review, and this paper is vehicle trajectory extraction using multi-UAV cooperation, captured simultaneously traffic data from multiple UAV from highway corridors. They use TUT video stabilization and yellow VA detection, deep sort for tracking, trajectory matching module using Maha, Mahan, Mahanlonbis distance cosmetics, and also use Hungarian algorithm for wavelet transform denoising. And in this paper, they generate complete area-wide trajectories. And this is the five papers that I have literature reviews, and this is all about my papers. Again, lastly, I want to again show you the videos. This is the annotated videos. You can see the annotated videos that use custom data set using COCO 11 a model. I track the vehicles using region of interest, considering the region of interest, and track the vehicle X and Y position overall. That's it all about my presentation. Thank you so much.